All right, in this video, I'm going to do a couple of problems from section 3.5. I'm going to start with section 3.5, number 34. And we see here that we are given h at t is equal to t times cosine t added to tangent of t. So when I go to take the derivative of this function, I know that I need to first take the derivative of the first term and add that to the derivative of the second term. So I'm going to start with the fact that I need to find the derivative, and actually I'll just go ahead and write that out. I need to find the derivative of the first term and add that to the derivative of the second term. Okay, now finding the derivative of the first term, I'm going to use the product rule again. So I have these two functions in here, t and cosine t. So I have h prime at t is equal to, now the product rule tells me that I'm going to take the derivative of the first term. So the derivative of t multiplied by cosine t. And I'm going to add to that t multiplied by the derivative of cosine t. Notice I'm just writing this all out. I haven't actually taken any derivatives yet. I want to show you the steps on how I'm doing it. And then I will add to that the derivative of the tangent of t. And in this unit, we learned that the derivative of the tangent of t is equal to 1 over cosine squared t. So I went ahead and took that derivative there. When I went from here to here, I did take that derivative. So now I'm going to come back and finish up by taking the derivatives of these, and putting that in its final form. So I have h prime of t is equal to, now the derivative of t prime is just 1. So I would have 1 times the cosine of t, and then add to that t times the derivative of the cosine of t. And the derivative of the cosine of t is negative sine t. And then, of course, I still have this 1 over cosine squared t. I'm going to clean this up just a little bit more because I don't need the 1 in there. We know that multiplying by 1, the 1 doesn't need to show. And I'm going to just clean this part over here up a little bit too. And that gives me h prime of t is equal to cosine of t, and then minus, I'll pull that negative sign out, minus t sine t plus 1 over cosine squared t. And then I'm done. I'm not going to combine those terms in any way other than that. That's the final version of the derivative of h of t. All right, now let me go ahead to the next one I'm going to do is problem 41 from section 3.5. And this one, we have a use of the quotient rule here. And we haven't done that together yet. So let me go ahead and write that out. I know that when I have, when I'm taking the derivative of two functions, one divided by the other, the rule is I take the derivative of the numerator multiplied by the denominator, subtract from that the numerator multiplied by the derivative of the denominator, all over the square of the denominator. So that's the rule we learned in section 3.3, and we're going to use that now. So I'm going to use my technique where I write this out. the derivative of p is equal to, so let's take, I'm going to need the cosine of t, the derivative of that, times the denominator, which is t cubed. Subtract from that the numerator multiplied by the derivative of the denominator all over the denominator squared, and the denominator here is t cubed, so I'm going to square t cubed. All right, now let me go through and actually take those derivatives. So p prime is equal to, all right, so the derivative of the cosine is negative sine, so I have negative sine t times t cubed minus, and the derivative of, well, I'll just say minus cosine t, and the derivative of t cubed is 3t squared. And then t cubed squared is the same thing as t to the sixth. Now, often, because we don't want to get confused here, this is the cosine of t being multiplied by 3t squared. So often what we'll do is we'll pull that 3t squared in front of the cosine, just so we don't get confused what's going on. But it's okay if you leave it in parentheses like that, you don't have to do anything else. But you might want to rewrite this as negative, and even here we could pull that, it's negative t cubed sine t minus 3t squared cosine of t all over t to the sixth. Either one of those forms is fine. All right, then finally, I would like to simplify this a little bit more because I see that in my numerator, both terms have a t that I can factor out. And so I'm going to do that. P prime is, and they actually both have a t squared that I can factor out. That would leave me negative t sine t minus 3 cosine t all over t to the sixth power. And then I can simplify this because t squared over t to the sixth is really just 1 over t to the fourth, if you remember your rules of exponents. And so then I can write that p prime is going to leave me with negative t sine t minus 3 cosine t in my numerator divided by t to the fourth power in my denominator. And that is my final simplified version of the derivative of p. All right.